Max, hello, hi.
Hi, Kasha. How are you?
Good, very nice to see you. So, Max will be telling us about patterning via electrohydrodynamic printing, EHD printing, and inkjet printers with a focus on the display industry. So, we look forward to this.
Sure. Thank you so much. So, before I share my screen, I'd like to start up to introduce myself. So, my name is Max Mosberg. I'm part of the business development and sales team at Notion Systems. We're a company that lives and breathes everything and anything inkjet and EHD printing. We're a team of roughly about 80 people. We have some locations scattered all over the world. But yeah, most of everything comes in engineering made in Germany.
Very nice.
I want to jump right into a crash course about inkjet printing. I mean, we've already heard a lot about inkjet printing in the previous presentation, but maybe get back to a quick overview of what it is in general, just for anybody that doesn't know. So inkjet printing, kind of like your printers at home, we print fluids onto substrates in the very, very basic sense. What we do at Notion Systems, however, is we print functional material. So we don't do any graphic printing. This would be a complete overkill with our systems. So our print heads we use in our printers have multiple nozzles. So this could be a couple of thousand nozzles per print head. And we have multiple print heads in one system. So we will have tens of hundreds of thousand nozzles in one inkjet printer potentially. And then we can also print multi-material with this in a fully automated function way to have a system configured for 24/7 mass manufacturing. And to kind of get you a sense of scale of what kind of size droplets we're looking at, 1 picoliter is a cube of a 10 micron side length. And with inkjet printing, our typical limit is somewhere around 20 micron feature sizes. So this would be an 8 picoliter droplet. And if you ramp up and go into more mass manufacturing, you're looking at a 30 micron droplet that we usually manufacture with. So as I mentioned, we have up to 100,000 droplets per nozzle per print head. So if you kind of scale it up to what I mentioned earlier, with multiple thousand nozzles per print head, with multiple print heads in a system, this will give you about this will give you a highly parallel, fully digital way of manufacturing or structuring your substrate. And we can individually choose when to print and what not to print. So this is what we call a drop-on-demand inkjet printing. So what can we do with this? Usually, if you look at electronics, this is a very, very general overview of what they look like in a side view. You can see that electronics are usually manufactured of individual layers. And somebody like me, I have a background in mechanical engineering. I have a background in additive manufacturing with producing large parts, always layer by layer by layer. You can kind of take the next step into taking the macroscopic additive manufacturing down to a microscopic or even on a nanoscale to manufacture those same layers in electronics with additive manufacturing. And this is what we can do with inkjet. All these layers here, we can actually print one by one instead of using the traditional subtractive method of manufacturing. So what does this look like in the end? We kind of separate our approach, this manufacturing, into two different approaches. One is the class 1 applications, and the second is class 2 applications. So let's look at a general lithographic process chain of manufacturing where you have a substrate, then you have a functional layer. On this functional layer, you print your resist, then you expose your resist, strip away the resist, and strip away, and in the end, you're left with a functional layer. So you actually build up a lot of material that you're going to eliminate in the end. So some of our applications, we're not only in the display industry, we're also in electronics in general, is that we print the resist directly. So we kind of eliminate two steps. And with display technology, we're actually even able to print the functional layer directly. So this is something very, very, very magical in my opinion. So what does this portfolio look like? So these are some solutions we offer our clients that are up and running in the field. So for one, we can actually print RGB active material. So this would be printing OLED material. Or quantum dots. Quantum dots is something that's very popular currently, especially with our EHD technology that I will touch on a little bit later. Second